Hello everyone, I'm Himani and I'm going to show an example of FP growth algorithm. We have this example, it has 8 transactions. These transactions have some items, so all the items which are present in transactions are A, B, C, D and E. So for the first pass of the data, what FP does, it finds out the items and calculate their counts. After counting, it will sort them and prune them on the basis of minimum count. So let us suppose that the minimum support count is 2, so all of them have, in this case all of them has the their count greater than minimum support count, so all of them will be there, and sort them in the order of decreasing count. So B will be at the top and C will be the lowest one. So it then before starting the second pass, it initializes the tree. The tree will be initialized and it contains a node which has null, that is nothing. This is called the root node of the FP tree. So after this it starts taking the second pass over the data. While taking the pass, it scans each of the transaction, and what it does in this transaction, it sorts it on the basis of frequent one item set list, which was in the decreasing order of their counts. So after sorting, it will get B, D, A, E from this transaction. So what it does, it creates a node B as a child of the root node. If it was already present, its count will be updated, but in this case it is not present, so it will create B as a child of root node. Then check for the D. If B contains a child node named as D, no, so it will create. Similarly for the A and E and maintain their count. So in this case, B has occurred once, D has occurred once, A is also has occurred once, E has also occurred once. In any of the transactions it has occurred once, so this path will be denoting the transaction. So this is the tree looking like this. It also creates some pointers which are from this list. This list will be pointing to the node with the same item name. So B will have this pointer to the node containing B, D will have this pointer to the D, A and E. Then we will also create the pointers when we will update this tree. We will see that in the further steps. Let's go on further. So tree looks like this. I'm not taking the pointers at each of these steps because it will create the tree it will create the tree looking messy. So let's see for the transaction 2. Transaction 2 contains these items, then again sort them. After sorting, you will get this B, D, A, E, C. Check the root node contains this item B, yes it contains. Then for the D, yes it is also there as the child of B, A is there as the child of A, E is also there as the child of A, but C is not there as the child of E. So what it does, it creates the child of E as a C and update all the others counts. So all these will be having the count 2 and C will be created with the count 1. So similarly for the transaction 3, for transaction 3 B, A, E, C, after sorting it will be there. Then again check that B is already present as a child of root node, yes it is present, but A is not present as a child of this node B. So we will create a node named as containing item A as a child of node B. So we will get B, A, E, C. Similarly, A was not having any child named as E, E was not having any child named as C, so we have created those and updated the count of B. Similarly, move on the next transaction. Before moving, it also create the pointers. I already told if we update the tree, we will create the pointer. So this A, this was pointed from this list, and it will point to the next node containing A. Similarly for the E and C. Right, so move on the next transaction, BAD. This transaction will be sorted, so it will look like this, BDA. Now check that root node contains B, yes, this node B contains D, yes, this node D contains A, yes. So update all of them, there's count. So it will look like B4, D3 and A3. Okay, so for the transaction 5, it is D. After sorting, it will only remain the D. So check that root node contain D. No, it does not contain, so create the one child node B for this root node. So we created this and updated its count. Similarly for the next transaction DB, sorted, we will get BD. B is already present as a child of root node, yes. B contains any child named as D, yes it contains, update the count. So we will get this. Now move on the next transaction, ADE. So sort them. After sorting, we will get BAE. So after sorting, we will get DAE. So we'll check that root node contain any child named as D, yes it contains. D contains the child named as A, yes. D contains, no, D do not contain. So we will create one. Similarly for the E, we will create it and update the count of D. Move on the next transaction, BC sorted. After sorting, we will get B and C. So we will check that B is present here as a child of root node, but C is not present as a child of this B. So we will create one and update the count of B. So it will look something like this, and C have the count 1. So this is our final FP tree. I already told we will be creating the pointers at each of the steps. So these are the pointers. So these pointers are there for E, for A, next DE. Similarly for the next C. These are pointed in this way. So this is the final FP tree. Now let us see how to extract the frequent item sets out of this tree. So for extracting it, we will move in the reverse order of this frequent one item list. First we will find out the frequent item sets for the C containing, then we will find out the frequent item sets containing E, then A. That this will be the suffix. No other item set contains C. Only the one containing suffix C will contain this. Above this, there is no item set containing C. We will see how it works. So first let us use suffix C. We will extract the conditional tree. So for extracting it, we move from here, go to the C, extract the path from C to the root node. Then for this C, we extracted this path. Then we move using this pointer to the next C, extract its path. Similarly for the next C, and extracted its part up to the root node, so it will have something like this. And we have treated the count of each of the node on the basis of the count of C below it, right? So we'll get this. So these are the paths. We B, D, A, E having this count 1, B, A, E having count 1, and 1 B where this C was there as a direct child, so 1 from here B. So we will check, we will create the combinations out of these and check that those combinations have followed the minimum support. If yes, then suffix them with C. If not, then do not take them. So for the single combination, we have B, A, and E. We will check them that their support count is following the minimum support. So for B, 1, 2, 3, yes, it is following. So we will suffix it with C. We will get BC 3. Then again for D, D is having one here and no one else here. So D is 1, which is not following the minimum support. Minimum support was 2, so we will discard D. Then check for the A is 1 here, 1 here. It is 2, following the minimum support. We will create it with suffixing C with A. Similarly for the E is 1 here, 1 here, 2, so we will get EC 2. Similarly we will make the combinations of size 2, then 3, then 4, and check. So for the combination of size 2, we will have AE, AD, and AB, EB, DA, DB, DE, something like this. We will check their counts. Like for AE, we have count 1 here and 1 here. So we update the count to be 2 and check it is following the minimum support. Yes, so suffix it with C and create the item set. Similarly, you can check for the BD. If you are checking for the BD, BD is present only in one path, not in this one, not in this one. So its count is 1. This will be discarded. So similarly, if you find out the combination of size 3, so BAE is the only one which is following the minimum support. So it is suffixed with C, and we will have this item set. So next, move on the next suffix E. So for E, we have extracted this parts. Here the count is 2 because इसके नीचे 2 E थे, इसके पास एक E था इसके नीचे, और इसके नीचे भी एक ही E था. So we are updated their counts. So we get these parts. Then again start making combination of single, then double, and check their support count and update them on the basis of minimum support after suffixing them with E. So for single A, D, B, we will check. A is having 2 here, 1 here, and 1 here, so 4. Yes, it is following, so suffix it with E, right? Similarly for the D, A, and B, then starts making combination AB, AD. You will check their support count. You can see DB is present here only in this path, so it has the count 2. So you can see DBE here. Similarly for the 4 item set ADBE, you can see the prefix ADB is present in this path, and it is having the minimum count 2. You will not take this count 3 because the minimum of this path is 2. So you will check this minimum with support count. Yes, it is following the support count, so you will suffix and create this item set. Similarly for the next one, A, we get these parts. This B, D with support count 3, then this B with 1, and this D with 1. You can see this B is having 4, D is having 3 because A was here, right? So we will start making combination. D having count 3 here, 1 here, so it is 4. So suffix it with A as it is following the minimum support. Similarly for the B, and start making combination of size 2. So we will get BD with out of these minimums count is 3, which is following the minimum support. There is more than the minimum support, so we'll create it by suffixing it with A. Similarly for the next D. So for the D, we have this conditional tree. You can see we are not taking any of the path from here, as D was only having null here, so null with D is only making the frequent one item set, which is D, which we have already extracted in past one, so we need not to take care of that. So we'll take this B4, we will check its count and suffix it on the basis of minimum support count. If it is following, yes, it is greater than 2, so we will suffix it and make our frequent item set BD. So this is the whole process. I hope this is clear. Thank you for listening.